Okay, so welcome back. So now we're going to talk about cardioids. So cardioids are of the form R equals A plus or minus B cosine theta or B sine theta. And again, A and B are both positive values, and by the way, the ratio of A and B is equal to 1, which means they have to be the same value. Okay? So these are the criteria for a cardioid. Okay? And the cardioid can be either one of these types of equations. Now notice again, cosine goes horizontal, okay, in the x direction. Sine goes vertical in the y direction. Okay, so again, very similar to circles, right? When we're dealing with circles, notice that it's like a circle, except it's got this piece, this extra piece here, right? Before, circles was A cosine theta or A sine theta. So again, so the difference between a circle and a cardioid is just this extra term that's being added or subtracted here. Okay, so it just has that extra term. So what does this cardioid look like? It looks like sort of like a heart, you know, like a heart, kind of mashed up heart. So it's like I guess maybe sort of like a circle, but it's got this pinched in or this poked in end on the side. So notice that if it's plus with cosine, then most of the circle or the cardioid is on the positive x-axis. Okay, if it's a subtraction with cosine, then you've got most of it going towards the negative side on the x-axis. Okay, and then if it's sine with positive, then most of it's going up, versus if it's subtraction with sine, then most of it's going down. Okay, so that's the best way I can think of to kind of remember the orientation of this stuff. Now notice again, just like circles, okay, we've got symmetry, right? So symmetry, it's symmetric with respect to the polar axis, okay, or the x-axis, if you will. Here, when you're dealing with sine, you've got symmetry with respect to theta equal to pi over 2, or the y-axis, okay? So these are the characteristics that you want to keep in mind. And again, the steps are the same steps that we did before. You want to look for symmetry, right? Test for symmetry. Then you want to look for zeros. Okay, where is the radius 0? And then also you want to find what angles do you get the maximum value of r, right? And then once you have those things, then you plot the typical points that we look at. You know, pi over 6, pi over 3, pi over 4, pi over pi over 2 pi over or pi over, well, what is it? 3 pi pi over 2. Obviously, there's another one I'm missing. So 5 pi over 6, and so on, right? So again, why? Because we want to see what the pattern looks like. Okay, so again, this is something you're going to want to review, and you know, if you memorize it, great. You definitely want to know them. Okay, so let's do an example, and then we'll move on.